Okay, before I get to example 2, let me talk about the difference quotient, which is this, f of x plus h minus f of x over h. This is something that you need to be able to do before you get to calculus. So this being Geo Trig is somewhat of a pre-calculus class. We want to get to the point where we're able to simplify the expression like this. Today we're going to deal with simple polynomial functions. They get more challenging. This same difference quotient shows up again when we get rational functions or radical functions. So what we're going to do this year is we're going to learn how to do the algebra to simplify that. In calculus, then we'll do some calculus to it in order to use that expression to find some stuff. Okay? But this is what a difference quotient is. It looks a little intimidating to most people, but here's what's going to happen. They're going to give you f of x. They're going to give you a function. They might say y equals instead of f of x, but just pretend it says f of x. All right? And f of x is given to you, so this right here is something you already know. H is the letter h, so you already know that also. So the only thing you don't know to begin with is f of x plus h. And as you can see, step 1, find and simplify f of x plus h. Change x to x plus h, simplify it out. If it's x to the second power, it's going to be x plus h to the second power. Then you have to square it and all that stuff. If it's 3 times x, it's 3 times x plus h, then you have to distribute a property and stuff. So find and simplify f of x plus h. Subtract f of x from f of x plus h. You'll find that f of x lives inside of f of x plus h plus a couple extra terms. So every piece of f of x should also be an f of x plus h. We'll notice that, hopefully. And once you get both of those things, you subtract f of x from f of x plus h, you got some remaining pieces, put those over h, and then everything should have an h on it so they all cancel out. Okay, you will see it demonstrated in the next problem. So let's watch this. Determine the difference quotient. So again, once it says the difference quotient, it immediately means f of x plus h minus f of x all over h. That's what difference quotient will always mean. So, to make f of x plus h, we take function f of x, which is this function. We change x into x plus h and do whatever is happening to x plus h. So 3 is being multiplied by x squared, x is being squared, so x plus h has to be squared, and then plus 7. I'm replacing one object x with multiple objects x plus h, so I have to put parentheses around my substitution. Whatever happens to x plus h. Continuing to simplify this, 3 times. Okay, you always want to square things before you multiply them. So x plus h squared is going to be x squared plus 2xh plus h squared. This happens almost every problem. Okay, especially right now there's a couple where it's just x, okay? But if it has x squared, x cubed, x to the 4th, x to the 5th, or anything, you're going to have to usually multiply that times something else. Make sure that when you simplify x plus h to a power, that you keep that expression in parentheses so that then the distributive property takes over and we need to multiply 3 times all 3 pieces. The most common mistake people make, they do this, but then they just do 3 times x squared. So this is this whole thing, 3 is being multiplied by that whole thing, so distributive property occurs. So 3x squared plus 6xh plus 3h squared plus 7. That's what f of x plus h looks like. That's step 1. I recommend doing step 1 outside of this problem because that's where all the hard work usually is to begin with. All right? Once we create this, it tends to get easier as long as it's a polynomial. If it's not a polynomial, we'll tackle that when we get to it. So, if I take this difference quotient here, h goes on the bottom, right? F of x plus h goes in front, so I'm going to take this expression, 3x squared plus 6xh plus 3h squared plus 7. Now, this is very tame looking, but I want to be very cautious about this. It says minus f of x, right? F of x is 2 things, right? So it's going to be minus the first thing and minus the second thing. Be very careful. Minus f of x minus 3x squared plus 7 minus the first thing and minus the second thing. Make sure both of those signs change. All right? Notice 3x squared is part of f of x plus h. minus 3x squared, those cancel. Plus 7 is a part of f of x plus h, minus 7, those cancel. That should happen every single time. If it doesn't, you probably forgot to change one of these signs over here.
What if it's already negative?
If it's negative over here, it'll be positive over here.
Okay.
Because if let's say it started off minus 7 here, that'll all be minus 7, right? Then when you minus 7 is plus 7, they're still opposite. So that opposite thing should always happen. All right? And once I cancel out all the, you see f of x always lives in f of x plus h plus a couple extra terms. All right? So f of x should always go away. What's left is a bunch of terms containing h. So I get 6xh plus 3h squared all over h. And since every term contains the letter h, division by h is legal. So I end up with 6x plus 3h as my difference quotient. From here to here, we're dividing the h out, so just over 1, I just leave that over 1 out of it. I just leave it as a non-fraction. So that's what we're looking for on a problem like that. When we get to rational and radical functions, they're not as friendly. But the polynomial functions all work like this. The ones you have in your homework tonight either have x to the first power or x to the second power. And they're pretty straightforward and they'll work pretty much like this one.